In U5A4, we're going to be balancing redox reactions. Now, this is very important in things like battery technology. Battery technology, as you probably know, is a huge thing right now, especially with the advent of the electric car. So the first thing you have to be able to do, and I'm going to split this up into part 1 and part 2, is you have to be able to do oxidation numbers. So oxidation numbers are where we assign a charge to an element in a molecule. So what we're going to do is learn some rules. If you know 4 basics, the rest is easy. It's just adding numbers up. If it's a group 1 metal, it gets a +1 charge. If it's a group 2 metal, it gets a +2 charge. Hydrogen, which is not a metal but in group 1, is +1. Oxygen is -2. If you remember those things, then we call those the knowns, then we can figure out anything else. So one type of question they might ask is, what's the charge on the manganese? Well, we know each oxygen is -2, so -2 times 4 is -8 altogether. We know that the potassium is a group 1 metal, so it's +1. All you gotta do is go on the periodic table. Potassium's in column 1. And there's only one of those, so that's +1. Now, everything has to add up to 0. So what that means is +1 plus -8, what will equal 0? +7. So that means the manganese is +7. Okay? So what you're going to do is you're going to get knowns and unknowns in each one, and you have to figure out which one is the unknown. So if oxygen is -2 and there's 3 of them, that's -6 altogether. Hydrogen's a known, it's +1 times 2 is +2. Sodium is in group 1, it's +1. Right now what we have is -6 +2 and +1. So that leaves us with +3 to get this to add up to 0. So that means that the phosphorus is +3. A couple other little things to think about. When if you have something that is a 1- charge, like nitrate itself has a 1- charge, well, oxygen's 2- times 3 is 6-. What that 1- charge means is the whole thing has to add up to 1-. So what +6- gives 1-? 5+. Your nitrogen would be 5+. Now, another thing that you have to be aware of is if you have something like this, where let's say X was -2, there's 3 of them, that's -6. That means the A would have to be +6, but you have 2 of these, so each one is +3. Just a couple of the little things that can occur to sort of throw you here, but there's not too much. Now, there are a couple of exceptions. If hydrogen is attached to a group 1 element, so it is only the group 1 element plus hydrogen, the hydrogen now becomes 1-, the group 1 metal becomes 1+. If there's any other elements in here, this rule doesn't hold. This only works for LiH, NH, or KH. Another exception, if you've got 2 of something from group 1 and 2 oxygens, the oxygen is 1-. We call this a peroxide. Folks, you got to recognize the pattern. Any element from group 1, you have 2 of them, plus 2 oxygens, you have a peroxide. The oxygen is now 1-. Here's the last one that I want to do. Let's say that you have 2 unknowns. We don't know what P is, and we don't know what Cl is. Neither of those are group 1, group 2, hydrogen, or oxygen. If you don't know, you can do a reverse crossover. So you take the number that's down there and you put it here. You take the number that's down there. If there's no number there in chemistry, it's understood to be a 1. If it comes first, it's positive. If it comes second, it's negative. So we've been able to deduce what the charges were on these by doing a reverse crossover. What you can see if you look on a periodic table is that many of these elements only have 1 charge, but some of them have more than 1. Oops, I can't find it in this particular periodic table, but some of them have all of the charges in them. Right now, I am not seeing that. Oh, I do. Okay, so for example, lithium is 1 plus. Right above my pencil, there's a little 1 there. Beryllium's in group 2, it's 2 plus. But if you look at a lot of the elements, like I'm going to look at phosphorus right now. Phosphorus can be plus or minus 3, plus or minus 4, plus or minus 5. So if you look in your periodic table, you might see the potential charges that elements can have.